So I've basically drawn 3 different lines on a set of coordinate axes. Now actually let's give it a name. So let's say that this is line A, this is line B, and this is line C. Can you tell me which line is steeper?
Which line is what?
Which line is steeper? So do you understand what I mean by steepness?
Is it the slope?
Yeah, exactly, it's the slope. So which line has the highest slope? Which line is steeper if you're going to walk up it?
C?
Yeah, exactly, it's a C. Okay, so this one's going to be the steepest. Which line is the least steep?
B.
B, perfect. Okay, so we say this is the shallowest. And then A is kind of, well, it's somewhere in the middle. Okay, this is somewhere in the middle. Now, how did you know that?
From the line?
Exactly, you were kind of looking at the direction of the line, weren't you? And you were basically imagining, well, okay, if I was going to walk, imagine this was a hill. If you were going to walk up this hill, that'd be a lot more hard work than this one. Okay, because this one's only going a little bit up, that one's going really up. Okay. So as a mathematician then, I want to come up with a way of defining this steepness. Okay, I want to come up with a way that I can compare these 3 lines categorically to work out which one is steepest. Now, this is where the idea of a gradient comes in. Now, what I would like is just a number. Okay, so what I would like is a value for each of these steepnesses, each of these slopes. And what I would really like is that the value of the gradient, the value for this line, the steepest one, should be higher than the value for this line, which is the shallowest one. Okay? So in other words, the value of the number, the bigger the number, the steeper the slope. That's what I want. Okay? Can you think of a way of defining steepness? Just looking at those, if you had to say to somebody, well, okay, I can see from the line that this one's steeper and this one's the shallowest and this one's in the middle, but could you come up with a way of putting a value on each of these 3 lines?
Numbers.
Exactly, so how could I come up with a number for each of these 3 lines? How could I calculate a number? Just purely from what I've drawn. I'm trying to use the x and the y coordinates as well. Can you think of any?
Maybe if the y numbers is more,
Okay.
the x numbers is less.
Okay, good. So you're trying to compare x and y's together, aren't you? Fantastic, and that's exactly what we're going to do. So what I'm going to propose to you is that the way to come up with steepness is literally doing what you're saying. We're going to try and compare the y to the x. Okay? In this case, what I'm going to do is I'm going to define steepness. So I'm going to define the slope of the line as simply, instead of moving 3 across or 2 across or 1 across, what happens if I just move 1 unit across? How many do I move up by? So let me write that down, okay? So if I move 1 unit across, how much do I move up or down by? How much? Okay. That is going to be my idea of gradient. So if I want a definition of gradient, I've just decided gradient is to do with the steepness or the slope. If I want to put a number on it, this is how I'm going to define it. If I just move 1 unit across, 1 unit to the right, I should say. Where's my rubber? 1 unit to the right. It's how many I move up or down. So just by moving 1 unit to the right, how many do I move up or down? Okay? So, let's see in each of these 3 cases, if I just move 1 unit across, how many do I move up or down by? So for the first one, okay, I need to work at some, so for line A, I need to work out some of the coordinates. I need to work out some of the points that I know lie on the line, okay? Well, are you happy in this case that there's a point here at 1, 1? There's another point here at 2, 2. And there's another point here at 3, 3. Okay? So if I move 1 unit across, if I move 1 unit to the right, how many do I move up or down by?
double.
Not quite double. Have a look, okay? Actually, there is another point which I forgot to put on here as well, which is of course 0, 0. If I just pick any of these points which I put in here in red, okay? So let's suppose, for example, I just pick 0, 0. If I move 1 unit across, okay, how many do I move up or down by?
1.
1, exactly, okay? And if I do it at another point, for example, this point here, if I move 1 unit across, how many do I move up or down by? 1 again. And if I move 1 unit across, how many do I move up or down by? 1, okay? So in this case, because if I move 1 across, I also move 1 up, okay? The value for my gradient in this case is going to be 1, okay? Now I suppose it makes sense to give our gradient a letter. I mean, G would make sense. We don't actually call it G, we call it M, okay? We call it M. Okay, so M is our gradient. Don't ask me why it's M, it just is, okay? It makes sense, I agree, as G, but I think G is to do with gravity and stuff. So basically our gradient for line A is M. M equals 1. Because if I use 1 across, I move 1 up. Make sense? Good, fantastic. Alright, so now if I look at line B, well look, I need a few more points, okay? Because I know it's a straight line, I'm not actually going to go in for all of the individual in-between points, because the in-between points, if I look at 1, it's going to be 1 and then some non-integer, like it's not going to be 1 or 0 or 2 or a nice number like it was up there. So what I'm going to do instead is just look for a point which I know is a nice integer, nice round number. I think this point here, okay? So this point here would be 3, 1, and actually this point here as well, which would be 0, 0. Does that make sense? Okay? So I'm just picking 2 points that I know are nice round integers. So in this case, I can't just do 1 across. What I'm going to do instead is say, well, look, I know if I move 3 across, I move 1 up, okay? So I know that fact. If I move 3 units across, I'm going to use 1 up, right? So then I can translate this to say, well, okay, instead of moving 3 across, if I just wanted to move 1 across, here's my question. How many would I move up?
3. No.
3?
Negative.
Not negative 3. I mean, look, what have you done to get from 3 across to 1 across? What have you done to that 3 to get to 1?
Divide.
Divide by 3. You made it 3 times smaller, haven't you? You've said, instead of going 3 times the distance, only going 3 times less distance. So instead of going 3 across, only go 1 across, you're making that number 3 times smaller, which means you're also going to have to make this 3 times smaller. So what's 1 divided by 3?
1 over 3.
A third. So if you go 1 across, you're only going to go a third up. So you're happy that in that case, our gradient is a third, okay? Because our definition isn't interested in going 3 across or 5 across or 7 across or 2 across, it's only interested in going 1 across, okay? So because I knew that if you go 3 across, you go 1 up, that must mean, by default, that if you go 1 across, you only go a third up. So in that case, our gradient is a third. That makes sense? All right, let's do it for the last one. So again, I'm only going to find points which I know are integers. Okay, so this point here is an integer, it's 0, 0. But also this point here is an integer. Let me just make sure that line definitely does go through that point. Okay, I also know this point here is an integer as well. I know this point here is 1, 3. Does that make sense? Alright, so in this case this makes sense. So if I go 1 across, how many do I go up by? 3. So I go 3 up. Okay, so in that case, I'm going to say that my gradient is equal to 3. Perfect. So let's just review what we've done here. Okay, for this first line, let me write down the left-hand side. For this first line, I got a gradient of 1. For the second line, line B, I got a gradient of a third. And for the third line, I got a gradient of 3. Okay? So does this satisfy the thing which we wanted at the beginning? We said that this line, line B, is the shallowest line, and this line, line C, is the steepest line. Okay? Does that work? Do these numbers reflect that this is the shallowest, this is the steepest, and this is in the middle? These numbers reflect that? Are you sure? So m equals 3, m equals a third, and then m equals 1. So we said that because this is the shallowest line, it must have a number, so the value of the steepness should be the smallest. That's a third, okay? Because it's the steepest line, this value of the steepness must be the biggest of the three. That's 3, and because this line is kind of in the middle, that line should have a steepness which is somewhere in the middle, okay, which is 1. I think that does work, okay? Because if this is the shallowest line, it's got the smallest number. This is the steepest line, it's got the biggest number. This line is in the middle, so it's got a number somewhere in the middle, okay? So formally speaking then, how are we going to define gradient? How are we going to define our formula? Because there is just a formula which you can do. Well look, I'm going to play on this idea. If I move 1 unit to the right, how much do I move up or down by? Okay? Have a look at this example here. Have a look at this example here. Because this example, we said, well look, we can't quite move 1 across at the start. We ended up saying, well okay, I know if I move 3 across, we move 1 up. Then from there, we managed to work out what happened if we just moved 1 across. So what you need to do here is you need to take however much you move up or down by and however much you move across by and divide them by each other. Watch what happens. If I take this example here, so just look at these two numbers here, 3 across, 1 up. If I take however much I move up or down by and divide it by however much I move across by, then are you happy that because I move 1 up, I put 1 on the numerator, and because I move 3 across, I put 3 on the denominator? So the reason why I put 3 on the denominator is because I don't want to move 3 across, I only want to move 1 across. Okay? So therefore I've got to go 3 times less distance, which is why I have to divide by that 3. Does that make sense? Okay, so that's where my third comes from. So in general then, the formula for my gradient, is going to be however much I change in the y direction, however much I move up or down by. So I'm going to write change in y, and I'm going to have to divide that by however much I move across by. Okay, so that's going to be my change in x. Okay, so change in y divided by change in x. Now if you don't like writing change all the time, you can always write difference. So the shortcut for difference is just that little capital letter D in the Greek alphabet, which is delta. So it's going to be change in y divided by change in x, delta y by delta x. Okay, and that's my formula for gradient.